my pleasure to introduce to you the next lecturer. And his name is Professor Myomo King of the Department of Civil and Environmental Engineering, Seoul National University, Korea. The theme of his lecture is Urban Geohazards. Professor King has had a very impressive educational career. He had his BS Civil Engineering from Seoul National University here in Korea. He had his PhD from University of Colorado, Boulder, United States. And between 1997 and 2000, he was the editor-in-chief of Korean Society of Civil Engineers. Between 2003 and 2005, he was president of the Korean Geotechnical Society. And between 2007 and 2009, he was the director, National Geotechnical Earthquake Engineering Laboratory here in Korea. The title of his paper is Susceptibility Assessment of Rainfall-Induced Landslides, a case study of the debris flow of July 27, 2011 at Umeonsan Mountain here in South Korea. Please join me in welcoming Professor Kim.
Good morning, everyone. Well, it's my great honor to be here to give a talk in front of many esteemed scholars. Well, as is shown here that I retired from university for several years ago, even if I'm still working on engineering business. Actually, it was co-authored by two professors. One is Professor Chung Sang-sum at Yonsei University, and he's the president of our society. You should have met him yesterday during the opening ceremony. And another co-author is Professor Yoon Chan-young at Gangnam Wonju University. And I want to say thanks to Dr. Kim Jong-han, who is a research associate in Yonsei University, and he helped me in preparing this presentation. Dr. Kim. And originally this paper was focused on the susceptibility assessment of landslide, but I changed it to the focus on debris flow itself, and to discuss some disputes between the residents who were bereaved and suffered damage, property damages, and the Seoul city, and also insurance companies. Okay, this topic is, microscopically speaking, is urban geohazard. Okay, and these days it's very famous. Hurricane Irma, you should know, and Hurricane Harvey that struck Florida and Houston. Well, Hurricane Harvey just sank the whole city of Houston a couple of weeks ago. And now, but in our country there's no hurricane. And I just wondered what's the difference between the hurricane and typhoon. And some of you may know it already, but I just searched on the internet and I found that hurricane and typhoon and cyclone, those are the same weather phenomena, but they have different names because they developed over different locations, different ocean. So for example, hurricane, if it developed in Atlantic Ocean or northeast of Pacific Ocean, then that's a hurricane. And typhoon that we experience this from Philippines, and it goes up through Taiwan and east coast of China, and then it just passes between Korea and Japan. And cyclone, that's that occurs south part of Pacific Ocean and also Indian Ocean. Okay? Well, there's one more thing, which is tornado, but it's a totally different thing. Okay? It just occurs over the land, not the ocean. Okay? Anyway, so we talk about well, the title is susceptibility assessment, and also it is included in my talk. Now, what do I do? Okay. Okay, the contents like this. Overview of the Umyeonsan. Well, Umyeonsan, san means mountain, okay? And we use the identical character, Chinese character, China and Japan and Korea. And Japanese, they read it Yama, but san means a mountain already. Now, the main event occurred in 2011, but here it says 2010 and 2011. Yes, there was a small-scale debris flow in 2010. So if the Seoul City engineers, they realize that there's a forewarning of the main event, then they should have done something. So in this respect, well, actually, I was the chairman of the forensic investigation team, and I conclude that it's not totally a natural disaster, but partly man-made, because they had a chance to prepare for the debris flow, which occurred in 2011. Okay? And then assessment of the landslide will be explained, and then I'll talk about the concluding remarks. Well, the concluding remarks is rather for our forensic investigation. Okay, all right. Here, well, this is Umyeon Mountain, okay? And this is maybe the southern edge of Seoul, and here's another Gyeonggi province. And this is a very large road, and actually the Seoul National University, where I worked for 30-some years, located here, and I live here. So every day I just use this road. Okay? And here just you cannot see the building, but it's 15 to 20-story buildings. They are condos. We call it an apartment, but actually it's the condos owned by the residents. Okay? And this is Dogu Am is a temple, and this debris flow occurred the area. And this is another one, Shindong-am. Oh, okay. Shindong-am means that's a brand name of the condos. Okay, and well, we are geotechnical engineers, so we just check the slope, landslide places, these two spots. Okay. This is the photograph which was disputed, the Seoul City after the big events in 2011, and everybody criticized that they didn't do their work, and then they just disputed the press release, and there they included these photos, and they were almost boastful that they have done everything they could. But that means they were really ignorant, and they were not ready to work for to prepare for the bigger one. Okay, it was just to finish the 78%. But what they did is they just repaired the damaged part. Well, at the time, actually, they should have checked all the areas, and then, even if they could not finish the work, but at least they should have started. Or like setting up the emergency evacuation plan, something like this, but they have done nothing for it. So we had a big, the next year debris flow ruined just the whole area around the Umyeonsan.
밤새 내린 비로 강처럼 변한 서울 남부순환도로. 우면산 꼭대기에서부터 하얀 물보라를 일으키며 도로 위로 토사가 밀려듭니다. 도로를 덮친 토사는 가로수를 쓰러뜨린 뒤 곧장 아파트 단지로 달려듭니다. 같은 시각 다른 동에서 지켜본 우면산입니다. 정상에서 시작된 산사태가 마치 폭포처럼 산기슭을 타고 도로로 쏟아집니다. 어마어마한 토사에 지켜보던 가족들도 혼비백산합니다.
Yeah, that was provided by a resident who was living in Shindong condo. Okay, and this is the road, which is 8 to 10 lane road, and actually I know that there are many debris flows occurring in Hong Kong and Japan, and they have a much larger debris flow incident. But in our country, it was just the first time. We just experienced, we have never experienced this kind of thing, so we all shocked with this instance. Okay, so, well, 2011, July, well, actually, debris flow occurred on early morning on July 27th. And 16 casualties occurred, and the property damage is just up to 15 million. And among the 33 debris flow area, Ramian area was the largest. Flow the largest soil volumes, and it had the steepest slope. Okay, it shows the whole debris flow areas. Okay, 33 debris flows, and 151 spots there landslides occurred. Okay, and there are 13 watersheds. Okay. And here I want to tell you that there are two meteorological stations. One is here, which is Namhyang, and the other one is Socho. I think the water rainfall measured in this area was close to the reality. Okay, now it's a susceptibility assessment. And now we just investigated a site. Okay, the left photograph shows the land before the landslide, but still you can see that there are residential areas which was developed too close to the mountain. Okay, and this is after the landslide. And for the close investigation, we just took these two areas. This one we had just to answer to the disputes. Okay, you will see what it is. And well, this table shows the watersheds and number of debris flows, and well, number of landslides and so on. Okay, this is Ramian watershed. Well, 3 casualties occurred, and the Ramian condo is standing here. Okay, and there's a channel length and width and mean incised depths and so on, and there are 4 spots where landslide occurred. Okay, and this is the soil slopes. Okay, this red dotted line that's just taken from the aerial photos taken in 2009 before the debris flow, and the blue line after the debris flow. Okay, the depth was 2 to 4 meters, actually. And just looking downwards, and the lines maybe is there for surveying. And this one, that's a Ramian condo. You see the logo, this is a Samsung, it says Samsung. It was built by the Samsung Construction Company. Okay, there are the crews who helped our investigation. Oh, I forgot to tell you that at the crest, there's an Air Force base. I don't know what they're doing there, but maybe it has something to do with a radar, okay? And it failed. Well, actually, in 2010, there was a small-scale failure also, but they repaired it, but it failed again, and you will see how they repaired it. And you can see that many trees toppled down, and we found that the root length was even shorter than the depth of colluvium, which was about 1 meter. Okay. And the geologists, they found that thin clay layers that just made to form the perched water table, and then soil slided above it. And this one just shows all, well, the top left, it shows the wide channel, and right hand side, it's just muddy debris. Well, the small particles just moves farther, so at the bottom there is just the clay particles. And then, well, one of our team just expressed this one as a formation of natural dams, but I don't know whether it's adequate. And just every flow consists of soils and rocks and woody stuffs. Okay, this was Dokwan watershed. Dokwan means the temple. There's a small temple there. There's no casualty, but this one experienced debris flow in 2010, and you will see that. Well, that's just. It looks very flat, but it's not. Something wrong with it. Okay, you see here that in 2010, this is the Air Force. Okay, this is a fence, and the small scale slow failure occurred, and then this is the photograph after recovered. But what do you think? I think this is just work done by a landscape architect. Well, it cannot be the civil engineering work to prevent the further debris flows. Okay, so next year, well, it's more larger scale. The landslide occurred here, the same places here. Downward, looking downward. Well, similar. Okay, now that's a Hyungcheon watershed, and that also there's a dispute. Well, actually, there's an ecological park, and here's a dam, reservoir, and that also, of course, that failed. And the residents around here, they just wanted to know whether the misadministration of the reservoir just increased the damage. Okay? But our conclusion was the other way around. Well, okay, see. As you see here, here's the dam area. You see that, well, just on the contrary, the sedimentation occurred, okay, rather than eroding. So maybe some of the debris flow was caught in this area. Okay. See, I think this is the deposited debris, I think. Okay, this looking upwards. Well, this was a dam was here, and here's a spillway. Well, the size of spillway is very small. Well, actually, it was constructed long time ago for agricultural purposes. Okay, so even if they open the spillway all the way, they should have broken. Okay, and this is just a normal streamline, but debris flow just moved in this way and then broke the dam. Well, right after the incident. Okay, now geotechnical investigation. Well, here it says first investigation, second investigation. Well, actually, I was the chairman of the second forensic investigation team. Right after the debris flow incident 2011, the Seoul City ordered the investigation, and the Korean Geotechnical Society executed the investigation. And at the end of the year, they submitted the report. But the problem was the residents who suffered the damage didn't accept the report. Okay, so the Seoul City reordered the investigation. And then at the time, I just managed the investigation. Okay, so the first investigation team, they have just say these all the black and white spots are the boreholes executed by the first investigation. And the red and white spot, that's we have done the test. Okay. And the seismic prospecting, just to confirm the soil depth. And the in-situ permeability test as WCC, you will see the apparatus, and ball shear test run, and direct shear, and SPT, and so on. Well, this is typical soil profiles. Okay. Okay, that's SWCC test apparatus. The Fredlund, I think he's, if I remember correctly, he's the big man in unsaturated soil mechanics. Okay, and using this, we got a relation between the volumetric water content and a metric suction. Okay, and using this relation, we just evaluated the degree of saturation of the ground. And to modify the lab test results, we just run the field suction test also. Tensiometer installed in 6 places. And from those tests, we just evaluated. We got the metric suction of dry soil and unsaturated soils in rainy season. Okay, these are the data used for the numerical analysis later. Okay, and the summary of soil properties, hydraulic conductivity, and initial water content, and so on and so on. And soil depth in Remnant Valley was 4 meters to 10 meters, including colluvium. 1 meter of colluvium, and dogworm also. And here's the map of the soil depth. They are also used as an input for the numerical analysis, which will be shown later. Well, actually, I reshuffled the slides, so it's a little bit tangled. Okay. All right. Now, I've shown you the geotechnical data, but the numerical analysis that just requires other data, like rainfall data. And here we got accumulated rainfall of 24 hours of this much, of which is quite large. Okay, and 1 hour rainfall was not here, but it's, well, it will be shown later. I think it's 100 and something, and it was within a period of 120 years. So it was just very severe in Seoul. Okay, this is rainfall intensity and duration curve, and you see many lines here. Well, actually, those are the thresholds suggested by many colleagues, and if the point lies above it, then landslide likely to occur. And this is a domestic suggested line by Hong and et al. And this is the point from Namhyun meteorological station. This is from Socho station, but both are above all the lines. So, and vegetation also, well, the root length and colluvium depth. Okay, this is 1-to-1 line. Well, this is obtained in our study, and they were all below the line. Okay, so the tree toppled down. Okay, here the peak intensity of 112.5 millimeter per hour. Okay, and in 16 hours it was 306.5 millimeters. And landslide activity related to heavy rainfall and loose colluvium, and watershed topography of high steepness and dense vegetation. Okay, and the debris flow activity is initiated by shallow landslide and hill slope and entrainment of surface water runoff from loose colluvium over bedrocks. Okay. Now, well, here's a general pictures. The top left shows the wetting band is coming down. Well, in this case, the ground is not fully saturated. It's not submerged, but still slow failure occurs because after the soil got wet, it loses the apparent cohesion which came from suction. Okay, and the right hand top, that's just that's a normal case. Okay, as just the water comes in, the groundwater level rises, and then in this case, even if the slope is not stiff, the failure occurs because the seepage force adds to the driving forces. Okay, And in this case, if you have an impervious layer here, and then when the wetting band reaches here, and then the groundwater level just rises, and then failure occurs. All right. In the numerical analysis, we just checked the two things. One is a shallow failure. The other one is deep failure. And shallow failure, that occurs within the wetting band. Okay. And deep failure after wetting band and the groundwater level crosses. Okay. All right. Well, this slide should have been much earlier, but I made a mistake here. And this is wire slope, which we use. And that one just requires the data from topography and hydrology and spatial data. Okay? And after all, with all this data we just execute the geotechnical analysis. Well, saturated, unsaturated, it can be handled here. And here's a flow charts, and I'm going to skip. Well, see, it's just general data and hydrological data, and then executes geotechnical analysis here. Okay, and for special purpose, we just run SIP-W or slope-W programs. And here just when we have a special dispute, we just verify it using these programs. Okay, you will see later. Okay, this is the result of analysis by wire slope. Okay, and left type 1, that means when we check the shallow failure, we got the factor of safety in this region. And right inside, that deep failures. And the circle tells you the spot where the real landslide occurred. Okay, and I think in this case, the deep failure occurred. Mainly the deep failure occurred in this area because it matches better with the landslide spots. Okay. But anyway, I think we succeeded to reproducing the field situation. And here we used SIP-W the program to check the residents just complained that the Air Force Base, the drained water, that just induced the damage or increased the debris flows. And so we checked it. But actually the water comes in from here. But if we just input the water from here, the program just bursted. So we had to just dispute water. But anyway, we still confirmed the adverse effect of the drained water from the Air Force. And this is Dogwon watershed. Well, in this case, very similar. I mean, the shallow failure and deep failure, the results are very similar because the failure depth was just about 2 meters. And so that just gave the identical results. But again, here we just predicted the failure as landslide very closely to the real situation. Okay. And in this case, we run the SIP-W just to check that. You saw that they have done the recovery work in this area, and I told you that it's just a level of a landscape architect's work, and we just use their recovered slopes, and we just run the program. We found that it was not adequate. I mean, it was unstable anyway, and which was confirmed in reality. And this one shows the Ramian and Dogwon watershed, just a local failure factor of safety. And on July 27th, it was below 1, so it was unstable, and actually the landslide occurred. Well, this is a different subject. Well, we have run the dynamic analysis. Okay, because, okay, you see here, this is a tunnel line. Well, they were just constructing tunnels, so blasting, they run the blasting. And the residents, they just felt the vibrations, and they asked to check whether the vibration facilitated the debris flows. Okay, so we checked these 5 sections. Okay. Okay, now first, this is Jonan Village. Okay, this is a tunnel here, and then Jonan Village is here. And then we check the slope stability of this one. And here, that's a Bodok temple. You see the temple here, okay? And in this case, the significance of this one was when we checked the velocity coming from the blasting was 0.27, which was very close to the limit. The limit in our country was 0.3 centimeter per sec, okay? But slope was okay. Okay, and here the Ramian apartment slope. This is a tunnel. And that's Songdong Village. And this is Jonan Village. Well, here, just ground displacement, ground velocity, as I said, the Bodok temple at the roof was 0.27. And slope displacement. And then we just checked the stability using the pseudo-static method. But the factor of safety, well, the change was minimal, nothing or very small, okay? And, okay, the 0.3 was allowable velocity of vibration, 0.3 centimeter per sec, but the largest one was 0.27, so it was okay. And this chart from Rita, okay, the displacement amplitude versus frequency, it ranged here. It's within the limit, but it was quite large actually. Okay, and looking at this map, this tunneling route, and these are the debris flow areas. And well, as you see that we cannot find any close relations between the tunnel lines and the debris flow area. So I thought it's irrelevant. Well, countermeasures, after all, we just used ecological planting and stone channels and soil nailing and concrete barriers. Okay, here's ecological planting and stone channels and then concrete barriers. And concluding remarks, well, actually, that's not the concluding remarks of this paper, but it's concluding remarks of the forensic investigation, okay? Well, landslides and debris flow occurred due to the heavy rainfall, corresponding to the frequency of 120 years at Namhyang Meteorological Station and 20 years in Seocho. Right, so I think it's close to the events. Recovery works executed for Dokwan Valley slopes were inadequate to maintain the stability of the slope for the future rainfall, as it was evidenced by the recurrence of the slope landslide. And the landslide occurred inside the Air Force Base, definitely participating in the debris flow of some valleys. And strongly, but we couldn't quantify it. I think nobody can. And strongly we believe that if adequate countermeasures were established for the whole valleys, including slopes in the Air Force Base around the Umyeonsan area after part of it experienced the landslide debris flow in 2010, the sacrifice of lives as well as the miserable damages on personal properties could have been prevented or at least dramatically reduced. The reservoir in Hyungcheon Valley is believed partly to have worked as a check dam, leading to less damage in the lower reaches, even if it caused the flooding in that area due to the collapse of the dam. The blasting executed for tunneling and underneath Umyeonsan several months before the 2011 landslide had a landslide had little influence on the well, the blasting had a little influence on the landslides. Okay. Well, okay, thank you for your kind attention so much for today. Thank you.